11.7 exam exercise. This is very important exercise. And in the first problem we have seen that there are 4 terms in the expansion of 2 plus x power 6 in ascending power of x. So we have to find the first 4 terms for this polynomial, higher order polynomials. So we will write down, solve it, this one, and by solving this part A, we have to find the coefficient of x cube in the expansion of this 1 plus 3x, 1 minus x, and 2 plus x6. So we will use this x 2 plus x6 here from part 1. So let's solve this problem. So this is 11.7 part 1. So 2 plus x power 6 is given as this. So we have to solve the first 4 terms. So this is 60, 61, 62 and 63. So for this one we have a powers n. This is n is here 6. So 61 c1. So this becomes n minus 1, and this is 1. This is n minus 6, and this is 2, and 4, 2, 6, 3, 3, 3. So for this we have to write down, this becomes 1, 2 power 6, and this is 6 here, and 2 power 5 x. So this is 6, 5, 2, 1. This is 2 powers 4, x square, and this is 6.5.4. So this is multiplying 6 multiplied by 5 multiplied by 4 divided by 3 means 3 factorial, 3 multiplied by 2 multiplied by 1. So we will write down like this. So this is 2 power x, 2 power cube, and this x cube. So on simplification we obtain this. So this is part 1. From this here we have an ascending order. X is increasing. So we will use this here in the part B. So for this part we have to multiply this to obtain this expression, and now in this place of this we have write down this. So we have obtained this 1 plus 2x minus 3x square, and this is this term. So we have placed it here. Now we are solving it. So we have to find the coefficient of x cube. So we know that if we multiply this one with this one, we will have a coefficient of x cube. If we multiply this one with this one, we have a coefficient of x cube. And if we this multiply with this one, we have a coefficient of x cube. So first one is this multiplied by this, and this 2x multiplied by this term to get this value, and this multiplied by this to have this x quotient, x power 3. So these things on simplification we have obtained 64x cube. So the coefficient of x cube is 64. This was the problem in problem number 1. This was the requirement of 1. Let's move to problem number 3. So here we have a coefficient of x square in the expansion of 1 plus x power n, where n is a positive integer, is 3 by 5, where n is a positive integer is 3 by 5. 3 by 5. This n is 3 by 5. Find the value, the coefficient of x square. This 3 by 5 is the coefficient of x square. So when we expand this, the coefficient of x square will be 3 by 5, and we have to find the value of n. Okay, and in the part B, using this value of n, find the term independent of x. So we have to use this here. The expansion of this one is used here to find out the value of n, where the term independent of x. So let's move to the problems. Let's solve the problem 3. We have given this information, and the coefficient of x square is given as 3 by 5. So we have write down as a 3 by 5. This is 3 by 5. So this is the given information. From this we can write down the expansion of this as this. So here we can see that this x square is available here. So we will take out this term. So we will take out this term. So nc2 1 n minus 2 x by 5 2 power 2 is equals to this given information 3 by 5. Now we will solve it, and this x power coefficient is equivalent to this. So this is the coefficient of x square, which is equals to 3 by 5. So we equate it and we will solve it like this. So this is n minus 1. So this is 1 2 1 power. The power of 1 is always 1. So 125 35. So we simplify it and eventually obtained as this. So for this we have n is equal to 6 or minus 5. The minus 5 is not possible, so n is equal to 6 is the solution. So second, in the second part, we have to find the term independent of x. So we have this given information. This is 1 x plus x upon 5. So we have solved it, x upon 5. So in solving this, we have this relation. Okay. So this part is this. For n is equal to 6, this part is this, and for this 2 minus 3 upon x square is this. So we have to find the value independent of x. So we will multiply this with this one. So we will have a coefficient without x. So this multiply by this multiply by this, and this multiply by this. So this multiply, and this is also 4 and 1. So this is again, so this coefficient, this divide by this, multiply by this, and this multiply by this. So from here we have this value obtained, and this is minus 5. The term independent of x is minus 5, that is obtained here. Now moves to the problem, another problem. Let's move to the problem number problem number 8. Use the binomial to expand a plus b power 4. Give each term in the simplest form. So here we have a plus b power 4, and we can write down this a plus b4 by expansion of the binomial series, and hence find the term independent of x in the expansion. So we will use it in part 2, and this part 8a2 could be used here in place of this. So okay, the coefficient of x cube, we have to find the coefficient of x cube, which is equals to 5n by 2. So find the value of n. So we will solve this part 8, this question number 8, part A and B, from A to B, and then 8b. So let's solve this question number 8 here. This is question number 8. A plus b power 4 is given as this. So we know it very well. So we have write down this, and we eventually comes this. This is a simple question. The term independent of x is obtained as this. So this is 2 and this is 2. So this x power 2, this is x power 2, and the denominator will cancel out, and we'll obtain this 24 upon 5. On simplification of this coefficient, we have this. So this is a term which is independent of this in terms in the expansion of this. So part B, we have to find this coefficient 1 plus x power 2 x upon 2 power n, and this is equals to 5n by 12, means the coefficient of x cube is this. So coefficient of x cube in the expansion of this x cube would be this. Okay, so n c3, so n minus 3, and this is 3. So this is x cube. So from here we have this n minus 1, n minus 2, this here 1 2 3, and this is x power 2 power 3 is 8. So we will solve it, and the coefficient of this x cube is equivalent to this. So this coefficient would be equals to 5n by 12. So we have this. So from here we have x cube, coefficient of x cube is here, and this coefficient of x cube is here, so we can equate it and eventually solve it to form the two different values of x. This is not possible, so the n is equal to 6 is the value which is the desired value. So we have solved the problem number 8. Now move to the next problem, the problem number 10. So the first three terms of a geometric progression is 2k plus 6, k plus 12, and k respectively. The first three terms of a geometric progression. This is a. 2k plus 6 is equivalent to a, and k plus 12 is ar, and this k is ar square. All the terms in the progressions are positive, so these are all are positive. So every term is positive. So find the value of k. So we'll use it to find the value of k and find the sum to infinity. After getting the value of k, we can find the sum to infinity. So for this, let's solve this problem number 10. So this is 2k plus 6, k plus 12, and k. These are the three terms of a geometric progression. So we have to find the value of k. So from this is a, this is ar. So by the ratio of these two, we can obtain the value of r is equal to k upon k plus 12. So this is similarly, this is ar. The ratio of this is r, and for this is ar square, and this is ar. Ar square divided by ar is again r. So for this ratio is here, and for this ratio we have this. So as a result of this, we have to use these two expressions to equate it and solve it. So this k plus 12 whole square, and this is k 2k plus 6. So we will solve it, simplify it, and obtained is as this: k square minus 18k, k square minus 18k minus 144 is equal to 0. On factorization, we have obtained k is equal to minus 24 and k plus 6. K is equal to minus 6 is not possible, so k is equal to 20. So this was the value of k. So we have obtained the value of k here. We will use this k to obtain the a value, which is k place value of a here to get the value of a. So in place of A, which is equals to 24 into 2 is 48 plus 6, 54. So in place of A we have write down 54, and A is 54. So 1 minus R is given as 24 divided by 24 plus 12 divided. So R is obtained like this one from this one. So we have obtained this value of R as this. So in place of this R we use here to find the value of S, that is 162. So this was problem number 10. Let's solve problem number 13. So the second term of a geometric progression is AR, that is second term of a geometric progression is AR is equal to minus 576, and the fifth term is 243. Fifth term means AR4. AR power 4 is equal to 243. Find the common ratio and find the first term and the sum to infinity. So we have to find all these three. So let's solve exercise problem number 30. This is problem number 13. AR is given as minus 576 and AR4 is given as, the fifth term is 243. So this is fifth term. So by using these two we can obtain R3, R power 3 as this. So from this we can take out and we get this R value as 1.33, which is equals to minus 4 upon 3. So we'll use this 4 upon 3. So get the value of A. So we will divide this by R, which is minus 4 upon 3. So if we divide this by minus 4 upon 3, we get the value of A. So which is 432. And by substituting this R and A to get this value of S, the sum to infinity, which is equals to 432 A 1 minus R, and R is given as minus 4 upon 3. So in place of R we write down minus 4 upon 3 and solve it and gets a value of 185 2 by 7. So this is part question number 30. Now solve question number 15. The sixth term of an arithmetic progression is the 10th, 15, problem number 15. The 10th term of an arithmetic progression is 4. The 10th term means A plus 9D is equal to 4, and the sum of the first 7 term is minus 27. Find the first term and the common difference. So we have to find the value of A and D. And the second part, the first term of a geometric progression is 40 and the fourth term is 5. Find the sum to infinity of the progression. So we have to solve this 15 number problem. So A10 is equal to A plus 9D is equal to 4, and S7 is equal to minus 28. From this S7 we have write down this expression, and so we have A plus 3D is equal to minus 4, and for a plus 9d is given as 4. So we will use these two to find the value of b. So we'll use it, and by simultaneously solving it, get the value of d is equal to 4 upon 3, and by using this d in place of this, we get the value of a. So we have to find the value of a equal to this. So d and a is obtained. So this was the requirement. In the part B, we have a is given as 40, and the fourth term is given as 5. So we will use this to get the value r cube is equal to a4 divided by a. This is a4 is a power a r cube. So this is 5. This is 40. So we write down for this 5, and in place of a 40. So r cube is equal to 5 upon 40 means 1 over 8. So r is equal to r cube is equal to 1 over 2 cube. So r is equal to half. So in place of this, a is 40 and 1 minus r is half. So we'll place this half here. So sum of the infinity is obtained as 80. So this is solved. So similarly, we can solve other problems. Let's solve problem number 16. The geometric progression has a first term a and a common ratio r, and sum to infinity is s. Another geometric progression has a first term 3a and common ratio 2r, and sum to infinity as 4s. Find the value of r. This is a problem that has to solve. So, and in the part B, we have a different question. The arithmetic progression has the first term minus 24 and nth term is minus 13.8, and the 2nth term is minus 3. Find the value of n. So this is part B. So we'll use this data to calculate the value of required values. So part A, we have a1 is equal to a, and r1. For the first progression, we have assumed it r1, and for the second, we have write down this. For the first progression, geometric progression, this is first sum of the first geometric progression. This is the sum of second geometric progression, that is 4 times the first progressions. So this is a, this is 3a, and this is r2 is 2r corresponding to this. This information is given, so we have to find the value of r. So for the sum of geometric series of first geometric progression is a upon 1 minus r, and for the second we have this information. So this is the first term, so we have write down this instead of this, and this is this, and the ratio of this is also given as 4. So we can write them, we can multiply this with 4 to equate it with this one, like this. So this is SGP2, and this is 4 SGP1. So SGP1 is here, and this is here. So we solve it and get the value of 5r equal to 1. So r is equal to 1.5. So we have obtained the value of r from this, and place it here. And for part B we have to solve. So a is given as minus 24 and an is given as minus 13.8. We have to find, and the a to n is given as minus 3. We have to find the value of n. From this we have an is equal to a plus n minus 1d. An is given as minus 13.8 and a is minus 24, and n is not given, so d is also not given. So we will place the value of these two informations to obtain n minus d, and d is equal to 10.2. And similarly for the second information, so a to n is equal to a plus 2n minus 1 d. Okay, so we will use it an in place of a to n is equal to minus 3. In place of a is given as minus 24, so this is 2n minus 2. So 2n minus 3 is equal to solve it to obtain this. So for this we have two values, n minus 1 d is equal to 10.2 and 2n minus 1 d is equal to 24. So from this we have 10.2 divided by n minus 1, and from this we have 21 divided by 2n minus 1. So we can equate it. So this 10.2 divided by n is equal to 21 by 2n minus 1. So this becomes this, and eventually the n becomes 18. So this was very important question, and it was asked in final examination. So this is all from chapter 11.